Okay, we want to find a function h that we're going to look at a level set of. We're given a function f that we want to look at the graph of, and we want those two sets to be the same. Right? So we're going to take the same basic strategy here. We want the set described by h equals c, and the set described by, let's see, I need to take the graph of this function. All right, well, that's a function of two variables, x and y. We'll form the graph by setting that equal to z, x e to the x squared minus y squared minus sine y. And I want these two sets to be equal. In other words, I want this equation and this equation to be equivalent, logically equivalent. So now, but I don't know what h is, but I can take this equation here and sort of manipulate it around until it looks like something equals a constant, because that's all I really need here. I need something equal to a constant, and I need that to be equivalent to this. So how about this? I'm going to take all the stuff on the right, toss it over to the left, z minus x e to the x squared minus y squared plus sine y equals 0. Now these are logically equivalent. And yet this one here, I've got something that I'm going to call h, and I'm looking at a level set of it apparently because I've set it equal to 0. Right? So h now is a function of x, y, and z, and it is equal to z minus x e to the x squared minus y squared plus sine y.
So it's really that easy.
Yep.
All right.
Yeah. So this is an interesting exercise. In fact, we're going to very often find ourselves in this situation where we've got some surface that's given as a graph, but I need to reinterpret it as a level set.
So this dimension now jumps to, this would be R33.
Yeah, h here is a function whose domain is R3, and yeah, this is a real valued function on R3.
Awesome.
Yeah. Yep. Okay. Yeah, so let me just finish the little story. I claim that there are many situations where we're going to have a surface that's given as the graph of some function, and we need to reinterpret it as a level set of some other function. Or maybe the other way around. Maybe you're given something that's given as a level set for whatever reason, and you need to reinterpret it, if possible, as a graph. So yeah, and you're right. I mean, it is. Once you see the trick, it's like, well, is that all there is to it? Well, yeah, that really is all there is to it, and it's nice that it's that simple.